Okay, welcome to the EpiDoc tutorials series. This is part of a series of short tutorials which you can find at the link below, introducing EpiDoc, the use of XML for marking up ancient documentary texts. In today's session, Elli Mylonas from Brown University is going to give us an introduction to the rules of XML syntax, and I'll pass directly over to Elli.
Hi there. So I will today present some information on the nitty-gritty, the details of how you actually encode XML and place it into a document, and what the rules are that you have to follow. So as you've already heard, XML is a very widely used way of marking up texts, primarily because it's the language in which the web is written. But in order to be very precise, XML itself is not an encoding language. It is the meta language that provides the components in which encoding languages are written. So for example, HTML is written in XML. So these components are the notation, the grammar, the syntax, basically the rules that can be used to define encoding languages. XML has a very basic concept of how a document, of what a document is. It is not the only way to conceptualize a document that one could use, but it is the way XML has chosen, the people who wrote XML have chosen, and it is what we use and work with now. So basically in XML, a document is conceived of as a tree. In other words, it is conceived of as a set of elements that can contain or be contained by other elements. For example, as you can see on the left, if we were to talk about a citation, a bibliographic citation, we might have an object that is the overall citation, and it contains three components: an author, a title, and an imprint. And that imprint also contains three components: the publisher, the place, and the date. This can be visualized as a set of nested boxes. It can also be visualized as a tree, with the citation being called the root of the tree, and then the author and the title are below that root, and the imprint as well, and then the imprint itself contains three more nodes, three more branches. In XML notation, this is described as follows. We'll ignore that little bit at the top that basically just says this is XML that you're looking at, so that an XML processor can then do XML things with it. But we have a citation, and that citation has an author, a title. I'm sorry, I have to look at the screen of the actual presentation on that title. And then here is an imprint, which contains a publisher, a place, and a date. Imagine nested parentheses. This is sort of a much more familiar way to look at this kind of structure. So in XML, a document is a tree, and a tree is a nested set of elements. Now, I'm going to be using I'm going to try to be very precise, and I'm using terms that are often confused and used instead of one another, and I'm going to try to show you what the proper way of doing this naming of names, of naming the parts of an XML document and of XML components is. So the basic building block of XML is the element. Elements surround text, and they have two parts: the start tag, well, they have three parts really: the start tag and the end tag, and then they have the content of the element. So the whole thing is called an element. Often you'll hear people referring to it as a tag, and that's kind of a shorthand, but really the tag is the start tag and the end tag. The tags, the name of an element is what appears inside the tags. So for example, I'm sorry, I'm getting a little confused there. The start tag contains the name of the element. The end tag is just like the start tag. It has the name of the element in it, but there's a slash at the beginning. So those are the two parentheses. And the content is whatever appears within. So start tag, end tag, the same name is within each tag, and the end tag has a slash. Elements may nest, but elements may not overlap. So for example, if we had, you might want to encode some poetry with a word break across a poetic line like this. You might want to surround each poetic line in the line element, which you can see has the start tag line and the end tag with a slash line containing the content of the line. But then we might have a word breaking across a line. So here the word omni breaks across line, and I might want to be marking words using the W element. And I say, well, the word is omni, so let's start the word element right before the O and end it right before the I with our start tag and end tag. But what happens here? What you're looking at is a line element, two line elements actually, with a word element, a W element, splitting across them, with a word element going across them. So basically you have line, line, and the W element overlaps the two line elements. This is bad. This is wrong. It is not XML. The W element is not contained fully within either of the line elements. Now, there are many ways around this, and the more you do with XML and different XML instantiations, you'll see different ways people have of getting around this. It's very easy to handle, but the way that one way that one could use is to say that the W element, which is incorrectly marked in this page, would start within the line, and then normally it would have an end tag there, and then we would put another start tag in the beginning of the second line. So we would essentially have two W elements, one within the first line, one within the second line. It's shown correctly in the image. And the more advanced ways of doing this might be to indicate that these two W elements are really one word. So elements may nest, but they may not overlap. Now there's another little bit of shorthand that's very important to know about. And if an element has no content, it may be displayed as follows. So instead of putting two tags, the start tag and the end tag, adjacent to one another with nothing in between, no content because the element is empty, we can show this conflated into one. Essentially what you have is something that looks like the start tag, but is followed by the slash inside the, right after the name of the element. And these two notations are equivalent. So empty elements are actually fairly important because they're used to show things like line breaks, page breaks, occurrences of some kind of feature in a text that may not be actually textual, that may not be a word. And these elements never have content. And in EpiDoc, they're referred to as, and in EpiDoc, they're referred to as milestone elements. So when you see this notation, it is not wrong. It's just that this is an element that has no content. Another bit of XML syntax is attributes. So elements have the ability, text is surrounded by an element, so you can identify in a prescriptive way, in a descriptive way, pieces of a text. So you can say this is a paragraph, a line, a word, an abbreviation, but you may need to provide more information about either the element itself or about its content. So for example, you might want to let's describe that in a minute. So the way attributes are incorporated into an XML element is that they appear on the start tag. So if we have a supplied element pointing out that this word Severus, in this word Severus, the S was missing, it was not visible, and therefore had to be supplied by an editor, the S is surrounded by the supplied element, but the supplied element has a reason attribute that explains that the reason it had to be supplied is that it was lost. In other words, it was missing. The attribute appears only on the start tag. I said earlier that the start tag and the end tag of an element are identical except for the slash. Well, that's not strictly true. If there's an attribute, it appears on the start tag. It does not repeat again on the end tag. That's a very common error that neophytes make as they start to use XML. And you can see that the attribute, well, actually, I think I'll talk about that next. So here we have the supplied attribute, and an element may have more than one attribute. So this gap element may have a reason attribute and a quantity attribute and a unit attribute, all of which, separated by spaces, appear in the start tag. And interestingly enough, the gap element is empty. So we just talked about empty elements. This is an example of an empty element. And it kind of makes sense, right? If you have a gap, what's inside it? So one more thing about attributes. Attributes have a name. So in this case, the name is reason, and they have a value. So as an attribute appears after the element name, you see the attribute name equals sign, and in quotes, the value. So attribute values can be constrained in a variety of ways. The easiest, perhaps, is that a closed list may be defined. Yes, no, lost or damaged. There can also be in XML a list of suggested or recommended values. So a list may be provided but may not be required. Or an attribute value may be a completely open list. So if the attribute is identifying people's names, well, you wouldn't have a closed list there. You could put in anything that you want. And so we did point out that attributes may have more than one value. In that case, values are separated by a space. This is a little advanced. But if, for example, you have a material, you're indicating the material of an object, and it has a type attribute. The object could be made out of wood and metal, in which case you might put in wood space metal if those are the values that are allowed. And finally, attribute values consist of alphanumeric characters and symbols. Sticklers will tell you that they may have spaces. A practical user of XML will tell you that putting a space in an attribute name is a very bad idea. So we recommend against it. There's a very special attribute. It's very important, the XML ID attribute. This can appear in any XML document on any XML element. And the XML ID attribute is used to identify an element. It is guaranteed to be unique within a document. It may not have spaces, and it must start with a letter. But the brilliance and the utility of the XML ID attribute is that because if you assign it to an element, you can always identify that element within that document without any doubt. So again, this is often supplied by your, it can be supplied by your XML software, but it's universal to XML. So we have now learned, discussed, and described the basic building block of XML, which is the XML element. So let's look at it again. And this image and a few of the other images, with many thanks to the Women Writers Project at Northeastern University because they draw beautiful pictures. An element has a start tag and an end tag, which surround content. The element name comes at the beginning. There may be an attribute, which has an attribute name and an attribute value. Note, by the way, that these are straight quotes. So sometimes if you're not using programmer software or XML software to create your XML file, your software will put in typographic curly quotes. Those don't work. The quotes have to be straight quotes, and this is a very minor little thing, but it can make your document not work. And then we have the end tag, which contains the same name as the start tag and has the slash in front of it. So that's all you need to know really about encoding XML. Everything is surrounded in an element, and elements may contain one another. Now we're going to talk about a few other details that are really helpful to know about as you work with encoding XML. White space, which is something that we're all quite careful with when we use Microsoft Word. I mean, do you want one space or two spaces? Is there a line end here? How does this all work? How does this all appear? This is not at all the way white space works in XML. So white space can be significant. In markup, it appears between the element name and the attribute name, for example, or between multiple attributes. In the text, you need white space to separate words. However, so in those cases, white space matters in XML, but the number of white spaces, so the number of white spaces in a row is not significant. You can have one space, or three spaces in a row. They will all count as one, they will appear as one, and they will be treated as one. For example, if you, in your text, had the word imperator, all the letters in a row, and imperator with a space between the P and the E, that obviously will be treated, the first will be treated as single string, and the second will be treated as two strings or two words, which is what you might expect because there's a space between the imp and the erator. Similarly, if you don't put a space between the name of an element and the name of an attribute, XML isn't going to know what to do with this. This looks like an element name, but then it's followed by this equal sign. This is completely, it's very nonsensical, and it will not be understood. However, if white space, as we said before, one white space or multiple white spaces, by the way, a white space is a space or a new line or a return. Any of those things counts as a white space. The difference between imp and erator and with a space in between and the same two strings of characters with a new line and a bunch of spaces in between, those are functionally identical as far as XML is concerned. Similarly, if you look at an element name that has a single space between the element name and the attribute name, and that has multiple spaces, that again, those are functionally equivalent. They do not make a difference. So you do have to pay attention to white space, but you don't have to pay attention to how many white spaces there are. So there's a fundamental concept of XML, of correct XML. So in a document, when there are no missing angle brackets or slashes or quotes, when you have the correct angle brackets, slashes, and quotes, when elements have matching begin and end tags, where so the name is the same, or the tag is empty, or the element is empty, see I used tag there. When all elements nest properly and are fully contained within one another and there's no overlap, And when there is a single element that contains all the other elements, in other words, when there is a root element, then the document is a well-formed XML document, and that is a term of art. If a document is not well-formed, it is not XML. It cannot be processed by an XML processor. It doesn't make sense. So well-formedness is the basic attribute, is the basic characteristic of that you have to achieve in order to have an XML document. Now, when you have a well-formed document and when you've applied the rules that we just talked about, you could conceivably have, I'm going to go back here. You could conceivably take a file with a text in it and make up elements that make sense to you. You could decide that you care about lines and paragraphs and words and names, let's say. You could identify these with your own well-formed XML elements, tag your file, and you would have an XML file. But the problem with this is that that is a very specialized file. It's the one you made up. And it doesn't really have enough constraint in it to make it very shareable, to make it reusable, and to make it understood by others, which are all qualities that were talked about in an earlier video. So there's another characteristic that an XML file can have, which is that it can be conformant to a schema. So a schema is basically a set of rules that defines the names of the elements that are allowed in the document and the relationships, the containment relationships of these elements. It will also define attributes and attribute values. So if you have a schema and you can apply that schema to your document, or if you can mark up your document within the constraints of the schema, then you will have an XML document that is valid. And then you can share the schema along with your document, or you can use somebody else's schema, and those documents stand a chance of being usable, reusable, shareable, and so on. So a file that has correct XML syntax is a well-formed XML file. A file that conforms and is correct according to a schema, to an XML schema, is valid. You can validate that file against the schema. And essentially, although you could in theory make XML that is only well-formed, in the context of research scholarship and open types of and shareable access, really it only matters if a file is valid and that you can explain which schema it is valid against. One thing that I just should note before we conclude is that as we read schemas and as we apply the markup that a schema recommends, we notice that the element names and the attribute names and the values make sense. For example, a paragraph is called P. A name is identified as name. And so it feels as if there are semantics that we are applying to this document. And we are, I mean, because the people who made up the schema were thinking of what names might make sense. I mean, you don't want to call a paragraph something irrelevant like line, because that wouldn't make sense. But as far as the XML software goes, those names mean nothing. The only thing that the XML software cares about is that the elements that have been defined with whatever character strings denote their names are in the right relationships. Which means that if P defines a paragraph and you apply that P element in a place where it's legitimate, but the thing that you're applying it to is not a paragraph, the XML software doesn't care, it won't catch you, and it won't correct you. So there are semantics implicit in a schema because people have written that schema, but there are no semantics required by XML software. And as we proceed, or maybe as you have already heard, schemas like EpiDoc come with guidelines. And those guidelines, which are written in prose and are human readable, are what really define the semantics of the schema. So I'll conclude with the examples of some well-known and less well-known schemas that sort of help you understand how people are looking at using XML. Well, the most broadly used and well-known schema is HTML. It doesn't seem like it's a constrained schema, but it is, and there is a definition of it. There's the text encoding initiative, widely used in digital humanities, and on which EpiDoc is based, is derived from. There's the music encoding initiative, which is a detailed schema for encoding music, DocBook for publishing. Someone tried to make one for knitting, EpiDoc, of course, and comic book markup language, one of my favorites. Thank you.
Great, thanks, Elli. I think that pretty much covers everything we need at this point. Is there anything we wanted to add? I'll put up the...
Are there any clarifications that you'd like to touch on, or?
From my part, no. I'll just put up the link there to the tutorials list again. If you want to find the rest of the tutorials in this series, you'll find them there. Thanks a lot.
Thank you.
Bye. Thank you.